nice intro there. At the Molecule dev team, we don't think in terms of lead developers or anything. So I'm actually just a senior Web3 developer. And this is how I would like you to think about me, because what I'm going to show you in the next 30 minutes is how we are minting IP-NFTs under the hood. This is what many of you might never have seen before, because we've all a beautiful front end in front of it. And I thought it's maybe a good chance using All-In to show you what's actually going on under the hood. This is actually planned as a workshop, so you can try to code along, but I noticed while putting it together, I think this is a little bit too complex. So I don't know who of you in the room is actually considering themselves a developer. Okay, there are not that many. This is why I think it's maybe better if we just go through the slides and show you how it looks like, and you can follow it up once you're at home if you want to try. Thank you very much. So, if you, in any case, want to follow along, there's a QR code that you might be able to scan. This is a GitHub repo that we put together just as test repo, so you can see actually code that's going to run. If you want to follow along, you're going to need some IPFS storage solution like Web3 storage. This is what we are using from Protocol Labs. And you need a private key that you can export from MetaMask or create on the fly or whatever you like to do. And just warning ahead, maybe not everybody's aware of that. Never, ever copy a private key out of MetaMask that you use on any public blockchain, right? Or on any mainnet blockchain, like Optimism or Mainnet. This would be a disaster. So, I didn't attend all the talks over the last 2 days. I think this question has been answered maybe several times already, but what's an IP-NFT? And I mean, there are definitely some definitions of that, but technically, it's an NFT with metadata on it. And you might have seen this one. This is my favorite example. This is Adolf. I think it's IP-NFT number 18 at the moment. And what's important is IP-NFTs have, well, the default properties that NFTs have, right? You have title, you have a description on the NFT. We additionally have some fields that identify them, for example, the research area, the lead researcher, which is a person that's attached as a JSON structure to it. You have the institution that's going to be invested in. You have some attachments. This is actually the most important part of IP-NFTs under the hood. And you have an artwork that's going to be shown to users. You know, when you talk about NFTs, and I guess many of you might have been involved in NFTs during the last couple of years, the artwork is actually the most important thing, right? Which is not exactly the case at ours. So the artwork, well, this is one of the nicest ones, but well, it doesn't play a role in the end. One important thing to note is the thing at the right bottom corner, which is the initial funding. This is actually technically just a value that's written on the metadata of the IP-NFT. This is nothing that's really a market value or that has been described by the market somehow. This is just a monetary value that we're attaching to the IP-NFT. Now, this is how it looks like on the front. Oh, this is how it looks like on the back. Right? So, since not that many people raised their hands when I was asking who of you is a developer, this is how it looks like if you look at an NFT on metadata level. So this is the metadata of the IP-NFT without a nice picture on it. Okay, so if you follow this talk and you think, I don't really get what this guy's talking about, but you want to try it out, you can try it out. We have a beautiful front end that allows you to mint IP-NFTs. It's called testnet.mint.molecule.io. You can also try it on mainnet if you want, but then you might be entitled to sell it to VidaDAO or something. So maybe you try it on the testnet first. This works on Curly at the moment. We're definitely planning to deploy this on Sepolia as well. This is the interface for it. Now, if you want to mint an IP-NFT, and you're going to notice that when you use the official front end, but this is what you also would need as a developer. Those are the things you need. You need a reserved IP-NFT ID. You need the general metadata information that I just referred to. You need the legal documents in place. You need to be aware that some of those elements are going to be encrypted, which infers creating checksums of them. I'm going to show you that in a bit. You need some decentralized storage level, where you can store the data. You need to be able to sign information upon the IP-NFT by the user who's minting something, which is what we call the terms acceptance and the permissioning layer. And you need 0.001 Ether, which is a symbolic minting fee. This is legally required and is usually around $10 or something. Again, if you want to try it out, scan the QR code while it's online. I always have the link to the repo on the right top side, so you can always copy paste that in your mind. So the first thing you do when you mint an IP-NFT, and I said I could demonstrate that live, but it's really hard demonstrating that with holding the microphone, so please bear with me that you just see the screenshots that I did yesterday night. The first thing you do is reserving an IP-NFT ID, and that is just numeric values, 17, 34, I don't know. In that case it is actually a 1, I guess. This is needed because the information you're going to put on the IP-NFT is referring to the NFT ID itself before it is minted. So we're going to assemble some legal documents that will refer to IP-NFT number 34 belonging to VilaDAO or something. That means you have to know the IP-NFT ID before the IP-NFT has been minted. And this is why we are reserving the ID before we actually mint it. This process is permissionless. Everybody can mint, or not mint, everybody can reserve as many IDs as they want. You can go at home, spend all your savings on gas fees and mint as many reservations as you want. Minting the IP-NFT is a different thing, but this is the reservation for the IP-NFT ID. Do we want to do the questions afterwards? Do you mind putting it down? Or is it really just shout it first and maybe it's simple to answer?
You said it's permissionless, so there's a smart contract managed by VilaDAO that issues those IDs, right?
The contract is managed by us. The contract itself is actually owned by Multisig. 2 of the signers of the Multisig are in this room, but we got 3 more, so if you kill us, there will be more people able to upgrade it. Yeah. So it's, the IP-NFT contract itself is living at Molecule, and the DAOs are minting IP-NFTs on the Molecule contract. Right, so it's actually a sequential value that's identifying IP-NFTs in sequential way. Okay, so the first thing you're going to do, you will build some kind of frontend as read it that's allowing you to put in all the NFT metadata, right? And this is what you currently see. Maybe the most interesting part of this one is how we're displaying or how we are putting the funding amount in there, and this is an international notation. So you can say it's funded in dollars, it's funded in euros, it's funded in Swiss francs, it's funded in yen. You can put that in that funding amount field. This is actually the initial funding amount that's gonna go into the IP-NFT once it's transferred to its first owner, for example, the DAO. This metadata is not changeable. So if you don't put anything in there, it will show 0 or nothing actually, which doesn't mean it's not worth anything. This is just a price indication. It just says the IP-NFT is gonna be, well, let's say somebody was willing to invest that amount of fiat money into their NFT. The next thing we're going to do is craft the legal documents. So as you might have heard, or I hope you're aware of that, there are some legal documents attached to those IP-NFTs. Now, where to get those from, right? So the first one is called the research agreement. Actually, it's not really called like that. There can be several of those. There are several ideas of how those could be crafted. I put some down here. For example, it could be a sponsored research agreement, a joint development agreement, patent license, or a so-called SAFIP. And we have a very nice example of the SAFIP on our repos. I don't know where's Jesse, he's talking right after, and you can approach him. He put that together. I actually prepared that so you can see what it looks like. This is really a legal document. I never read it. You can trust me with this one, I hope at least. And this is going to be negotiated between the DAOs and the research project. Now, the contents of this agreement are usually not public. They are not publicly disclosed. They contain information about the research project, about the researcher, about the stuff that's going to be researched. So this is something that you're going to encrypt in the next step. The second legal document that's currently needed to mint an IP-NFT is the so-called assignment agreement. On our very beautiful front end, this is going to be auto-generated for you. The assignment agreement is actually assigning the rights behind the IP-NFT to the new owner. So this is actually saying he's going to research on, I don't know, cancer research or something, the breast cancer research, and when this contributes to some kind of collective IP, this IP will belong to the holder of IP-NFT number 37, the reservation that we had before, right? This is what the assignment agreement is going to do. This is also going to be a PDF. We generated on our site. You can come up with totally different things, but it's on the be a molecule accepted IP-NFT if it contains those documents. You can basically attach any kind of legal document or any kind of document you want to that IP-NFT. So we have a completely flexible data structure that allows you to attach anything you want, and you can encrypt anything you want. Now, I talked a lot about encryption already, right? When you encrypt something and somebody decrypts it later on, let's say in 2 years because he got hold of the key, how does that person know that he decrypted the stuff that you have put in there? There's a chance that he decrypts something, but it's not maybe not exactly the content that somebody was uploading. So the first thing you do when you have your attachments in place, you're creating a checksum. We're using the multi-formats libraries from Protocol Labs to create a SHA-256 hash sum on all the contents. This is what we're doing in the background on our front end. This is how you could do it on yours. The repo contains a fully working sample how this is working. And those checksums in the end look like what you see at the bottom, right? So they come up with something that looks like a CID, which is not exactly a CID. This is just the hash sum of the document. Now, once you have that, here's actually the biggest magic in the whole protocol. When we encrypt, or when we talk about encryption, what we usually do, we mean lit protocol encryption. Now, I don't know if anybody of you ever have heard about lit protocol, but I would say this is one of the most amazing projects out there in the Web3 world. Lit protocol is a decentralized secret-keeping protocol. It allows you to keep secrets in a decentralized way, which is extremely awesome. So they have a network of distinguished nodes that all are building up the lit network, the lit protocol network, and those can keep shared secrets that are shared with clients. So, in a nutshell, what this protocol can do for you. You can tell it that you want to store a secret safely on the network, and each of those of their nodes just gets a little part of that secret. The full secret is on your machine. It never leaves your machine. Each of the nodes just gets a little part. Now somebody who's entitled to get the secret back, maybe 1 year later, in an end-to-end encrypted manner, this one is identified as an authorized user to get the secret, and all those nodes will signal back a little piece of the secret back to that user. No node in the network knows the full secret. But the entitled user who's getting the secret will be able to assemble the secret on his machine. And this is how you can actually distribute encryption keys in a safe and decentralized way among several participants. This is what we're using under the hood. I have a full code example also working in the repository. It sounds far harder than it actually is. You need to authenticate the user to use lit encryption first, and then you can just put any kind of binary data in there. This is going to be encrypted. You get the encryption key, and then you actually encrypt the encryption key with a lit protocol, store the encrypted encryption key with a lit protocol, or actually you can save it on your own machine, and attach that to the IP-NFT metadata structure. And then you have a fully encrypted file that somebody can download later on, and if he gets hold of the encryption key by lit protocol, he can decrypt that. Now, the question is, how does that key, or how is lit protocol authenticating that key, or that the user to be able to download that key, right? So how does the user, how do we know if a user is allowed to do so? Now, it's showing me emojis. Emoji time. The secret here is so-called access control conditions. So what you store on the metadata, this is again IP-NFT metadata, what you store there is a list of access control conditions that tell lit protocol which user should be able to get the encryption key. And this, you can try to read it actually. It says, okay, if that contract address, this is our IP-NFT contract by the way, if on GERD, if that contract, so if I call the can read method on that contract with the IP-NFT, the reserved IP-NFT number 76, and this can read method of that contract says this is good, so the calling user can read that contract, or the contents of the contract. Then the lit nodes will supply the key shards to the user. That means it's actually token gating. It says, okay, if you can prove that you have access to that IP-NFT on chain, lit protocol will give you the encryption key, or actually decryption key, to decrypt the encrypted research agreement on that user's box. It's like end-to-end encryption, but decentralized. Super awesome. And I don't want to talk about lit protocol actually, because this is not what we are building, we're just using it. But I definitely would advise everybody to have a look at this protocol because it's super awesome. And we are a validator on the network. Now, once you have the encrypted research agreement, the encrypted research agreement and the assignment agreement and an image or something in place, you're gonna upload that to a decentralized network of your choice. We're choosing for IPFS, but if you know your way around IPFS, IPFS is not really a persistent network. This is why you might consider pinning the content, using Filecoin to have persistence on it, and this is super complex stuff, right? One thing we absolutely can recommend is using some protocol or some service that's doing that for you. So we're not doing this on our own. This would be far too hard. We're using Web3.storage, also a service by Protocol Labs. Thank you for providing that one. Comes with a pretty good free tier, so you can just use that one to upload stuff. You're gonna upload the image, the encrypted research agreement, and the assignment agreement. And the storage provider will yield you back an IPFS CID. So you will get back the content hash, or the content address actually, of that piece of data. And this is what you then put into the metadata of the IP-NFT. Finally, now, what you have now looks something like that. Finally, C subcode, right? Even though you're already looking at it. That's more or less the final metadata structure. So it contains the metadata, it contains an initial symbol. This is what I never talked about, but this is just, well, it's just another metadata. You can choose arbitrarily. It contains the stuff I already mentioned. It contains the agreements array, which contains an SAFP, and the encryption definition. So how is this one encrypted, and what do I have to do to decrypt it again? And the assignment agreement, there will be some CIDs on it, so some IPFS content addresses. One of the final pieces is the terms acceptance. And this makes it a molecule IP-NFT. To mint that thing on our contract, you have to agree to the terms. Now this sounds pretty boring. Usually you just hit some checkbox, said, yeah, I agree to everything. In our case, it's slightly more complex. In our case, you really have to agree to this written text. This is exactly the text you have to sign. And you see that there are 2 lines in it that refer to the attached agreements. And those weird characters on the right-hand side are actually the content checksums that we created in the first step. So you sign that you agreed not only to molecules terms that you see in the front, but you also agreed to everything you are putting into the attached agreements. It doesn't matter if they're encrypted or not. You agree to the content checksums, which means, yeah, I really read the original. The result of that operation is what you see at the very bottom. It's a long string, which is actually a signature of the private key we're providing. What you do then is assembling the final metadata just by taking the accepted signature that you just have seen and upload that metadata file, which is just a text file, right? A JSON text file, to the final IPFS location. Web3 storage, or whatever you like. And now here it comes. Here comes the permissioned part of the whole protocol. We don't know what you are uploading there, so we actually do a last check, and this is running on our infrastructure. So what we ask you to do is, please send your metadata hash to our server. That server is validating your metadata, doing some magic things that we built and that we're not disclosing, so it checks if everything looks pretty much fine, like a real IP-NFT, decent one. Actually checks how your image is looking, if this is a nice image. I'm not talking about the rules here. And then it will yield you the final missing piece that you need to hit the mint button later on. I hope you can read that, but at the bottom there is the response of that service, and that service, I think I put it here, right? So you can, this is publicly callable. Everybody can call that and have it check the metadata. And this returns a so-called authorization byte array. So this is an authorization, which is essentially a signature of one of our relayers that says, okay, I looked at that metadata string, at the metadata CID, and the content behind it is valid. So schema is great, image is great. It's even a research area that we like. No, it's not doing that, so it's just checking validity actually. And with that, you can finally go to your favorite block explorer, use Foundry, whatever your favorite tool of blockchain interaction is, and call the so-called mint reservation method of the IP-NFT contract. It's called mint reservation because, as you remember, you reserved the IP-NFT in the first place some weeks ago, and then you took the whole process to finally come up with everything else. What you can do is, you can mint that thing to somebody else, and there's a reason why we did that. Let's assume you want to hand that over to a multi-sig, for example, the VDAL treasury. It's far simpler if you as a human mint that thing and send it to a multi-sig than minting it with a multi-sig, because then you have to sign off the terms with the multi-sig, which can be an extreme pain. So it's far simpler to mint the IP-NFT, or in that flow, to mint that IP-NFT as a human, or as an EOA, as a MetaMask account, or whatever it is, and then just in that transaction, send it to VDAL, for example, or to your target DAO's multi-sig. This is far simpler than minting it with this one. And I said, this is actually a legal requirement. You have to send 0.0, so that amount of Ether along, which translates to roughly $10. Yeah, so this talk already contained in its title and IPTs, but I thought this is so much information that I don't want to bore you with what IPTs are and how they are minted. I can only tell you IPTs are actually a simpler concept. IPTs are ERC20 tokens that are derived from the IP-NFT itself. Another thing, this is my first point here actually. You know, one of the hardest things to track on blockchains, I think you also asked that question some minutes before. One of the hardest things on blockchains is discover what is owned by whom, because there's usually not that kind of method on your smart contract that tells you who's owning what. It's just telling you, okay, this guy owns that IP-NFT. But we have a subgraph that allows you to query for IPTs, IPT belongings, IPT ownerships, relations with IP-NFTs, resolves all the token URIs, parts of the metadata, and everything else that you need to know to interact with all the molecule primitives. So I will share that anyway, or somebody's going to share it, and it's also public information actually. If you would click on that subgraphs link here, you're going to come to some GraphQL API that allows you to query anything from the IP-NFT and IPT protocol. Now, back to IPTs. What you could do now that you have that IP-NFT, you're going to see that on that very nice looking interface. Maybe you already have seen that. You can just go to the tokenized interface of that one. I can show you that quickly because we haven't seen anything of live demo here, right? So let's see. I hope I'm on the right. No, this is the wrong account. So how it usually looks like once you have created an IP-NFT, it will look like that, okay? Now, this one is not tokenized yet. There is a button, and this is what you, of course, also can do completely headlessly. You don't need the button for that. You can do this on-chain directly. You can say, okay, I bring this IP-NFT along, and I want to tokenize that further to 1 million CoFast, to your, however you would like to call your own token. And this one is then creating ERC20 token that's containing the tokenized IP-NFT. And this was not exactly the focus of this talk. I just want to drop it here. This doesn't mean that your IP-NFT is locked somewhere. The IP-NFT is now still movable. You only have a token that represents the governance rights on that IP-NFT. This is what an IPT generator is. But I think there's somebody right after me who's going to introduce you a little bit more to this concept. So this is something that's just running on chain. You can do this with one smart contract interaction. You can just tokenize the IP-NFT further. And I think when I hear that, I should close down, right?
You could 5 more minutes.
And oh, this was my last slide anyway. That's all, folks. Thank you very much for listening.
Thank you. Awesome stuff, Stefan. Awesome stuff. Awesome stuff, Stefan. And I think even I'm not a developer, but I could follow what you were showing us. And yeah, made a lot of sense. Thank you.
Sorry for not doing the live demo, but I said I got all the scripts on this machine. You can check it out, try it on your own. There's a question, if you mind, just bring it on back.
Thank you, and I actually have 2 questions that are unrelated. So the first one is that you're encrypting some things with the hashes, but then I was wondering if all the metadata is protected from being overwritten. For example, like the images and stuff. And the other one is, you also mentioned that you have this dependency on the wallet or like multi-sig to issue the IDs. Do you have like publicly available process for ensuring continuity on this multi-sig?
You mean continuity on the reservation IDs?
Well, basically, like you mentioned, like if we kill you off, like maybe a little wrong.
Go ahead.
Then like, what would be the process, like to recover or change it? Like, if people stop working. I'm just like kind of curious for general purposes. That's the second question.
Yeah, now let's start with this one. So the protocol isn't dying when Do and me are dying. This is great. So it's just permission messages will run forever. The problem is if you kill all of us, like all the 5, there's another one in the back actually. So if you kill really all of us, we can't upgrade it anymore. But that's it. So you can still use it. There's nothing that could go wrong there, right? So we are not controlling the IDs or anything. It's just counting up.
So then in which moment are IDs assigned? Like you don't need to sign?
No, absolutely not. So when you want to mint an IP-NFT, when you have the intention to do so, you're calling that a reserve method.
Yeah.
And he can do so 200 times, and he can do that 300 times, nobody cares. What you get out is some integer, 3,540. This is yours.
So you don't need to sign it off?
No.
Oh, okay.
This is what you do in the very end. The only thing you sign off is that you agree to the terms that rely on that reservation ID that belongs to you. Right, this is everything. You say, so I'm minting number 30 and I agree to everything. And we say, great, we heard that. The first question was about encryption. Since I didn't show the code, it's maybe not that clear. So we're only encrypting, or you decide as the minter, you decide what you want to encrypt, you don't have to encrypt anything. Now, you can encrypt one of the attached documents, which is the research agreement. This is most logical because this contains like non-disclosed information usually. You can encrypt that, put that encrypted CID on chain, and everything you download is the CID, right? And it's encrypted, so nobody can see the information. Now, somebody who's entitled to see it might be able to get the encrypted, so the encryption key from the lit network. But I think your question went to the direction, how do you update that, right?
No, like, if it's not encrypted and if I'm not dealing with the hash, I might have a pointer to the centralized storage, but I might overwrite it.
Yeah, the good thing is, so you cannot overwrite the metadata because our metadata is not upgradable. So there is no way how to upgrade it, right? It will always stay that sponsored research agreement. There's nothing you could upgrade there.
And what about the image?
You also can upgrade the image. This is always the same image. So imagine, and of course we're thinking about it, imagine you were able to upgrade that. I mean, you can just tell the smart contract that this is the new metadata. And then it contains a new image. That's essentially it. What you can do now, you can break it, right? You can say, oh shit, just override it with something that's completely illegit. Okay, you could try that, but on blockchain I can go back and see, no, the original metadata was that. Let's try to decode that, and then I still get the original document, because I can always go back in time on a blockchain.
Okay.
And there's nothing you could do about that.
Thank you.
Yeah, this is not a technical question, but a legal question. Is there any, is there any legal precedence about rights that people hold with these IP-NFTs?
Ask the next speaker, please.
Okay.
So
How do you deal with royalties?
Royalties on the IP-NFT, there are none. Because, I mean, it's very unlikely. It's a good question, right? So, if you sell an IP-NFT for $1 billion to buyer, you could do so. Maybe the original wants to have a share of that. Of course, this is the usual idea. I mean, I was the researcher, I want to have a share on that. Now, if you just look at IP-NFTs directly, the IP-NFT itself doesn't come with any royalties. So, well, you're lost. Which is, of course, super unfair, right? So you're the researcher, you created all the IP, why you're not getting anything. And exactly this is why we built an IPT process in there. So what you as researchers, you hand over the IP-NFT to the DAO. The DAO does a brilliant job in marketing this one and sells it to Pfizer. I don't know. And now, before doing so, the DAO is giving back IPTs like governance rights on the IP-NFT to the researcher. And the researcher can, when this process is happening, I mean, nobody's just paying $1 billion to an IP-NFT just right now, right? So there will be some negotiations going on. And with this governance power that the researcher has, he can tell the community that he wants to have $100 million out of that payment scheme, right? And then the community very likely will pay him out because, well, he held 10% of the whole IP-NFT. So there are no royalties, but there is some kind of shared governance. It's not really ownership, but a shared governance model that allows people to participate in the upsides of those IP-NFTs potential.
It's not built into the contract.
No, the contract doesn't care about money at all. And also not the IPT contract. The IPT contract is just there to represent governance rights on the proceeds of one IP-NFT project. But you can build one. I can even show you how to build one. But we're not publishing it.
Yeah, so maybe you partly answered, so it doesn't matter if you have the NFT and then you issue 100% of the tokens to someone, you can still move the NFT if you're holder.
Yeah.
It's just like representation. So.
Exactly.
Okay.
If you, and I wouldn't like to mention that term because we decided not to use it, but usually you would refer to it as fractionalization, right? In a fractionalization contract, you would actually say, as long as the IP-NFT is fractionalized, there is no IP-NFT anymore.
Yeah.
It's one of the fractions, and we're not doing that. The IP-NFT is still alive, it's still there, it can be transferred, it can be sold, it can be done with everything. But in the situation that it belongs to him as the DAO owner or as the DAO multisig or something, the commons behind the IPT holders, they form a common governance structure that decide what to do with the IP-NFT. This is how we are thinking. It's like tokenized ownership of the IP-NFT itself.
But that still needs a lot of manual consensus there. Like,
Exactly. And now we have to figure out how to do the governance, right?
Yeah.
We are just using snapshot voting in another multisig. So in VitaFast, for example, another multisig is holding the IP-NFT, and the VitaFast holders, they are actually now telling on snapshot what the multisig should do with the IP-NFT. And actually the next owner, so if maybe he decides to sell it on OpenSea, I don't know, for $1 billion, okay, he can do that. Now the proceeds of that sale, they will go to the multisig. And now everybody on the snapshot can say, but we want to have a part of it. They still have the IPTs. The IPTs are not bound to the IP-NFT anymore. The IP-NFT is gone now. But they still have governance rights on the multisig treasury. So they can say, well, now we're deciding that this guy gets 99% of it. They can do so, and this is how they're distributing proceeds potentially.
Do you have any existing projects you're minting NFTs for?
Yeah, absolutely. So there are, so on mainnet we currently have 4 IP-NFTs, and of course we have more on our older IP-NFT contracts, so this is like version 2.4 already. In all, I think we have around 12 IP-NFTs minted, and one of them tokenized, which is VitaFast. It's the token of the Dimitri Korojak project on VitaDAO.
12 from how many projects?
I don't know, but this is, I'm just a developer. You have to ask that. I'm sorry.
Six from VitaDAO and 1 each from Athena, Hair, Valley. Yeah.
Okay.
So it's like 9.
Just one last quick question.
Yeah. Why did you decide against creating royalties, essentially, on this one?
Now, royalties, I mean, first of all, you cannot enforce them anyway, right? So this is what we all know and suffer from. Blur, thank you. And the other one is IP-NFTs are of course not an asset that are just like changing owners every day, right? This is where you really earn a lot with royalties. It's more a matter of, so IP-NFTs represent intellectual property. They represent research project and research proceedings for intellectual property. And this is nothing that's just gets sold out of the box to somebody. This is going to be sold to only very certain people. I mean, Paul and Tyler are definitely the better people to talk about this aspect of IP-NFTs. But I, as a developer, will always see, okay, it's definitely an asset that's managed by groups of people and communities. And there's no real reason to have royalties on that one because they will always give something back to the people who do the research. This is all common research, actually. So you don't need that deep level of provision. I think we're over time, right?
We are. Thank you so much, Stefan. Let's give it up for Stefan.